Here we go. It's 2020, back in lab. I'm sorry, it's 2021. I'm thinking. We're gonna do some solubility experiments. First thing I'm gonna do is I'm going to calibrate these, or graduate these test tubes. These are 13 by 100 test tubes. What that means is the top is 13 millimeters across the diameter and is 100 millimeters long top to bottom, so 13 by 100 millimeter test tubes. I'm going to add a milliliter of water to this 10 milliliter graduated cylinder, and then I'm going to pour it into one of these test tubes and use a Sharpie to mark the height of 1 milliliter. Then I'll pour another milliliter. I'll put a marking at 1 milliliter and 2 milliliters, and then I'll do that for all the rest too. So let's start off with adding some water to this. I'm over at this scale, and I'm going to actually do a little side experiment. So sometimes these graduated cylinders can be off. So it says that when you fill to that line, it should be 1 milliliter, 2 milliliters, 3. Sometimes they can be off. I had one set of graduated cylinders where when I checked, the 1 milliliter was like 1.2 milliliters, 0.8 milliliters. They're pretty bad. So the way you can check this, it's easy. You just put your graduated cylinder in the scale, the balance, and you'll get the weight of it. You could record that and do a weight difference, but I'm just going to tear it. And then, so now the graduated cylinder is at 0. So if I fill this up with deionized water to 1 milliliter, what value should it read in mass? We are at about room temperature in here, so it should read about 1 gram. So that's one way, easy way to get an estimate of how accurate your graduated cylinder is. So here we go. I'm going to squirt a little more DI water in here, see if I can get it close. And you can tell, as I've said before, water is polar, and the graduated cylinder is made of glass. It's polar as well. That's why the water beads up and sticks to the glass, because they're attracted to each other. Like sticks to like, or like dissolves like. So the water beads are sticking to the glass. And that's why we see our normal meniscus at the bottom here. See how the meniscus, it climbs up the glass. So you get that. Let me get a better angle on it. Yeah, you get that meniscus going upward. So let me add just a little bit more. These should be set up so that your water meniscus, the bottom of it, is at the line. I think that's pretty good. What do you think? Pretty close? I like it. I'm gonna go with it, and then go down a little bit more. You can see. Yeah, so that's close enough. So this should weigh about 1 gram. Maybe it should weigh a little more because I've got some water stuck up here to the glass, but not much. Okay, so let's stick it in there and see what we get. Should be about 1 gram. 1 gram. Oh, look at that. 0.9982. I think 81. I think that's pretty good. I think this guy's accurate enough. So now what I'm going to do is I'm going to take this over and I'm going to go pour it into a test tube to find out how high a milliliter of water goes up in a test tube. This is going to be just a rough estimate of a milliliter. It's not going to be super accurate, but that's all we need for this experiment. We don't need to be very accurate with it. So I'm going to carefully pour in my water. Try not to spill any. There we go. See if I can get all the last little drops in there. Yeah. I think that's pretty good. Okay, so I've got my water up to this height in the test tube, the 13 by 100 test tube, 13 by 100 millimeters. So now I'll take a Sharpie and I'll mark off the height at the meniscus, the bottom of the meniscus of this. And now that will be my reference that I'll use, that height. I'll mark off the height of all these other test tubes. Now I'm sure these test tubes weren't made exactly the same, so this isn't going to be perfect, but it's closer than just a pure random guess of how much a milliliter would be in here. So I'm going to put a line on this one. I have to set the phone down for that, the camera. And then I'll add another milliliter and I will check it again. I've added another milliliter of water to my 10 milliliter graduated cylinder, and it looks pretty good. Where's the 1 mark? I guess there is no 1, it's just the 2. Oh yeah, there it is, there's 1. Couldn't see it. But yeah, it looks pretty good. I might be a tad over, but close enough. So now I'm gonna add that to my test tube that I already had 1 milliliter of water in, which I've actually already put a marking on. So if you could see it, there it is, that black Sharpie line there. So that Sharpie line is graduation for 1 milliliter. And now when I add my next milliliter, I'll be able to make a 2 milliliter line. Oh, before I do it though, let's check the weight of this. Should be, once again, it's 1 milliliter of water at about room temperature, should be about 1 gram. This one's a little bit lower, 0.9566. I did adjust my tare before I did this. I wonder if this milliliter is a little low, because I still have some sticking to the glass, but it's not too bad, I don't think. So yeah, it's probably within the manufacturer's error limits. Okay, so let's add this to our test tube. And now our test tube will have 2 milliliters of water. Okay, got it. So there it is, we've got 2 milliliters of water in our test tube. I've already got a line at the 1 milliliter height. Now I'll add a line at the 2 milliliter height, and then I'm going to put these lines the same height up on all the other test tubes for us. Before I pour out the water of this test tube that I used to graduate the 1 milliliter and the 2 milliliter volume, I think I'm going to measure it. So I'm going to measure from the bottom of my centimeter ruler here. And it looks to me that it went up about 1.1 centimeters from the bottom of the test tube to make a milliliter of water, and then about 2 centimeters up to make 2 milliliters. And you might think, oh, if it's 1.1 centimeter up for the first one, why isn't it 2.2 centimeters up for the second one? Remember, the bottom is curved. It's not a cylinder, a perfect cylinder, it's curved bottom. So yeah, I'll record that. This way, if later I want to measure up without having to weigh out water, I can just do it with the ruler. So I'll line up the bottom of all my test tubes, say a ruler like this, make sure they're straight across, and then I'll take a Sharpie and I'll just follow that black line across to all of them. So I have a 1 milliliter and a 2 milliliter graduation on these 13 by 100 millimeter test tubes. All right, there we have it. We have a number of test tubes now ready to be used for our experiments. Testing 3 different solids. We have this trans-1,2 dibenzoyl ethylene, it's a yellow solid, and the acetyl salicylic acid, it's a white solid. That's the scientific name of aspirin. This is the active ingredient in aspirin. If you've had aspirin, an aspirin tablet is almost entirely composed of this, some fillers, a little bit of fillers. And we also have succinic acid. Succinic acid is a solid as well, a white solid. So we have 3 solids, 2 whites and a yellow. And we're gonna also, we're gonna test the solubility of these, each of them, in 3 different solvents. We're gonna test them in deionized water and some flammable solvents. So we're gonna come over to our flammable cabinet. We keep all our flammable solvents in here. Open it up. And one of the solvents we'll be using is methanol. So I'll grab my bottle of methanol. It's a clear liquid. You can see it's looking polar, right? It looks like it's got a positive meniscus. It's growing up a little bit on the polar glass. Not as much as water, but looking like pretty good. So I'll bring my methanol over. And then I'm also gonna get a bottle of hexane. So I don't have N-hexane, the straight chained hexane all by itself, but I have a bottle of hexanes. Well, before I grab that, let's look, we got a lot of different things in here. We've got some ethyl acetate, toluene, isopropanol, ethanol, all these different flammable solvents. These are all mostly components of gasoline, so very flammable, and that's why we put them in this cabinet to keep us safe. And the one, though, that's interesting, a real common one we use a lot, is methylene chloride. That one, methylene chloride or dichloromethane, it's actually not flammable, but it's just put in here because it's a real common organic solvent. And so here we go, we got hexanes. We don't have the normal straight chain hexane. We got a mixture of hexanes, and this mixture of hexanes is basically identical polarity to N-hexane. So this will work perfect for our experiment because it's just a very non-polar solvent. And then we've got a pretty polar but not as polar as water. Methanol is pretty polar but not as polar as water, and water is the most polar. Okay, so it's before I start, I'm going to label my test tubes so I can keep track of everything well. I think I need a few more test tubes. I'm going to need 3 for the dibenzoyl ethylene because we'll have to test it in water, methanol, and hexanes. 3, oh, I might have just enough. Yeah, I do. Of acetyl salicylic acid, and 3 for the succinic acid. So I'm going to label those, and then I'll start measuring out my solid and adding my liquid and see who's soluble and see who's not. I've got them all labeled, and I really want you to label everything fully like I just did. It takes a little while, but it saves you from making errors down the line and getting things mixed up and having to repeat the experiment and not know what's going on. So what I did here is I put, like on this first one, DBE, dibenzoyl ethylene, water. So I'm going to test that solubility in water. And I put my initials and the date, 1/3/21. And then I've got DBE methanol, 1/3, MFS, 1/3/21, DBE hexane, MFS, 1/3/21. And then I've got the same for the aspirin, or AKA acetyl salicylic acid. And finally I have the succinic acids, 3 test tubes, all labeled and ready to go. I'm back over at the balance, and I'm going to start measuring out the trans-1,2 dibenzoyl ethylene yellow solid into my 3 pre-labeled test tubes. I'll start by putting a beaker inside of the scale and adding my test tube. I guess I'll go in order. I'll start with this one that's labeled for water. I'll put this in the scale tube, and then I'm going to zero this out. So now when I add the dibenzoyl ethylene to the test tube, that's all that'll be get weighed. I'm going to aim for 40 milligrams approximately. So this would be 4 here. So it'll be 1, 2, 3. Yep. So I want 0.040 is the optimal measurement, but anything close, so that's fine. Okay. So I'm going to grab my dibenzoyl ethylene, open it up. Cap down, and then now what should I do? Should I just try to sprinkle this in on the side? No, I don't want to do that. Should I go in for the top? Maybe up here, up on the top, just kind of 3-point shooter. Curry? No, don't do that. Don't do that. What I want you to do is I always want you to add your solid outside of the scale. Don't add solid or liquid to something inside the scale. I want you to take the container out of the scale, add it outside of the scale in case you spill. It's easy to clean up. Then we don't have a mess inside the scale. What happens is if a student spills a little bit in the scale and then they have someone else coming up behind them, for some reason this mental mind control takes over, and the next person sees that little bit of solid spill in here and they think that's what I'm supposed to do. And then the next person comes, they spill a little solid. Even if they didn't do it on accident, they purposely put a pinch on there. And the next person does the same. The next thing you know, you have solid pile of organic solids in here. We don't want that. We want to keep the solids outside. And when you spill them on the counter, don't leave them on the counter, because that also sends a message to the person behind you that, oh, we can just leave it when we spill it on the counter. All right, this is what I'm going to do. I've got my container outside of the scale, so I'll grab a pinch of it just to get a feel for how much 0.4 milligrams is. Add that to my test tube. Got that in there. I put it back in the beaker, and then I put this test tube I put the test tube and the beaker in the scale, and I check out the weight. So we're at 0.182. So we're not quite 40 milligrams. We're about halfway, huh? This is 18.2 milligrams. So what I'll do is I'll just take my container and just start dumping in. No, don't do that. Don't do it. Don't add it from while the thing's inside. You want to take this outside of the scale, set it on the counter, and add your solid or liquid outside of the scale. There we go. Gonna get about the same amount because we're about halfway there, huh? this is going to do it. I think that's the amount I want. Bring it over. Put it in the scale. See where we're at. 0.0375. I think that's close enough. That rounds up to 0.04. So I'm going to go ahead and write that in my book. Right away, write these things before you take them away. You're going to forget otherwise. So this is, what did I add for my dibenzoyl ethylene? Dibenzoyl ethylene? 0.0378 grams. That's what I got in there. Good. Now on to my next one. So I can take out this test tube. Grab the one that's going to be used for methanol and zero it out as well. So this test tube weighs a fair amount different, huh? 0.1 gram. So I'm going to zero that out. There we go. And I have to go get my other solid, huh? And remember to cap the solid that you just used. Okay, so let's come over and grab the... Oh wait, no, I'm sorry. I'm using the same solid. It's going to be a different solvent. Never mind. Keep that there. And now I'm going to bring this container again outside of the scale and measure out my dibenzoyl ethylene while it's outside of the scale. There we go. There's a little bit. Pinch. I'm going to do 2 pinches right off the gate. Right out the gate because I have experience with this already. 2 pinches in there. Put that in the scale. Let's see what it weighs. Ooh, 0.04756. That's a little high. So now I have a decision to make. Do I want to take some out or just say it's close enough? You know what? I'm going to go ahead and take a little out. It's probably close enough, but I'm going to take a little bit out. Now, the thing is, what do I do with it when I take it out? So normally people say the general rule is you never put reagents back in the stock solution, stock container because you don't want to contaminate it. But for our experiments, I know that this isn't, the purity of this isn't all that important. When we buy it, I think it's only like 98% pure. And I know that my spatula is clean. I cleaned it before I started. My test tube is brand new. I trust the manufacturer. So it looks clean. I'm going to remove some of this and put it back in the original container. I think it's okay. I know when you're in general chem, they might have had more stringent rules about things like this, but now you're advanced chemists. You can consider all of the variables of the situation and decide what's most appropriate. So let's see, I took a little out. Oh, look at that, 0.4245. I think that's close enough. I'm gonna go with that. So, methanol test tube for dibenzoyl ethylene has 0.04. It's saying 30 now. Close enough. And you know that it might make some of you cringe that I put this extra back in the same bottle, but you know it's a green chemistry principle too. Waste not, want not. You know, and if you know it's not going to mess up future experiments, then why do it? Okay, so I'm going to tear this one too. There we go, and add my aliquot to this one. There we go. Next scoop. Make it a little smaller. Okay, what are we at? Oh, I'm a little bit short, 0.033. So let's add it. Should I add more while it's still on the scale? No! Take it out of the scale, right? Put it back in the scale. Let's see what we got. Oh, look at that. Almost right on the dot. So let's go with this value. So this is for the hexane experiment. test tube. It has 0.040. This keeps rising. It might be gaining weight by moisture. I'm gonna go with 7. Okay, so we got our 3 test tubes ready. So we're gonna add solvents to these next and see whether they're soluble or not. I'm going to add water to the dibenzoyl ethylene and water test tube first. So I'll just use my water bottle here. And I'm gonna add a milliliter. I'm gonna add it to that first graduation there and see what happens. So I'm gonna set up my camera so I can see this a little better. Okay, let's go. About a milliliter of water. Is this going to be very soluble? I believe I'm about a milliliter. So far, it's not looking too soluble. I'm gonna grab the spatula, give it a stir, give it a real good chance, see what happens. Ooh, that's not looking too soluble to me. Looks like it's actually less dense than water, floating on top. It's not looking like it's dissolving much at all. Next up, let's do the methanol. Here's my methanol. I've got a pipette set up here, and I'm gonna try drawing up some of the methanol and seeing how well it holds it. This pipette might drip a lot at first, if you remember talking about that before. No, it looks pretty good. It's dripping a little. The pipette is gonna be cooled though. If I push out this first amount of methanol, drop some more, and push that out, it's gonna wet the inside of the pipette and evaporatively cool it, which will cause it to drip even less than it was in the beginning. So yep, is it dripping anymore? It's not. It looks great. Yep. So I can bring this over and start adding it to my second test tube. I'm gonna add again to the 1 milliliter line, approximately. So far, it's not looking like it's dissolving that much, but I think I'm a little short of a milliliter. I'm gonna add a little bit more methanol. Okay, I think I'm more at about a milliliter. And let's give it a good chance here. Let's stir it. Not looking too soluble. Maybe a tad more soluble than water, but really not all that soluble. My guess is that it is just too nonpolar for both very polar water and pretty polar methanol. Let's try hexanes next. Now we're going to go ultra nonpolar. My hexanes bottle is over here. I'll close off my ethanol first. Here's my hexanes bottle. It's our most nonpolar solvent. Let's look at the meniscus for this and see how this looks. So it should be pretty flat across. I'm not sure actually, because hexanes is very nonpolar. Glass is polar, so you don't expect the hexanes to climb up the side of the glass. It doesn't. It looks pretty good. I think it's easier to see in a more narrow container like a test tube than a big bottle like this. So let's get some out. Now the hexanes is more volatile than methanol, and it's non-polar, so it's gonna not be as attracted to the glass of the past your pipette. So let's see if it drips out a lot on the first drop. So if I drop some hexane, pull it out. Actually, it's pretty good. Oh, it's dripping a little bit. It's about the same as methanol. I think it's because this is winter right now, and the glass is cold. In a warmer day, like in the summer, the glass is warm. These non-polar solvents can just shoot out of your glass pipettes. Okay, so it's looking pretty good. I still like to have a good habit of drawing some up, spitting it out to evaporatively cool. And now I've got some my hexanes in the pipette. I'm gonna bring it over and add it to my test tube. To approximately 1 milliliter again. Here we go. I think I'm about there. Yeah, Okay, so hexanes, let's see. Maybe I picked a molecule that is not very soluble in any of these solvents. This is the first time I've tried this molecule, this solid, this year. Something new for you guys. So far, not looking too soluble. Let's mix it up. Give it more of a chance. Not looking very soluble. Well, maybe a little more. Yeah, no, it looks about the same as the methanol. It just looks like water is the most dense of these solvents, and that it's more dense than the solid. Let's do a side experiment. Let me try blow drying this. I'm going to heat it up with a blow dryer to see if I heat up each sample a little bit, if it changes their solubilities enough to have them dissolve. It does not look like heating made much of a difference. I didn't heat them all that much, but the little bit of heating I did do. It looks like the methanol, the solution is a little bit yellow, like it's dissolved some of it maybe. Okay, this sort of feels like a bad result, but it's not. It's just a result. It's just telling us that the dibenzoyl ethylene is not very soluble in water or methanol. They're probably both too polar, and it's not soluble in hexanes. It's maybe too non-polar. So I could just say, okay, that's the results, but I want to try one more. So what I'm going to do is I'm going to get the ethanol. So the methanol and water, I'm guessing, are too polar. So I'm going to come back over to the flammable cabinet and grab ethanol. And I believe that, I know the ethanol, which has an extra carbon, is more non-polar. So we're heading in between the extremely non-polar hexanes and moving away slightly from methanol's polarness. So let's try this out. So we'll open it up and pipette some up, see if it holds it or if it drips a lot. It's looking pretty good. Spit some out still, just to make sure that it's cooled, evaporatively cool. And I'll start adding it to a test tube, which I just weighed out. I didn't record the video of it. But this test tube, it has a 0.039 milligrams or grams of methanol. So let's add that to the 1 milliliter mark and see if the methanol, or the ethanol, I'm sorry, will dissolve this. Yeah, that looks like about a milliliter. So far, it's looking similar to the other 3 tests, but it's okay. These tests aren't too hard, right? Let's mix it up some. All right, so it looks about the same so far. Let's warm it up too. I'm gonna blow dry this one as well. Give it a full chance like I did the other 3. Look at that. It looks like it does start to dissolve in the hot ethanol. Yes, it's looking really good. And I did heat it maybe a little longer in the ethanol because I saw it start to dissolve compared to the other solvents. But yeah, it does look definitely that it's most soluble in ethanol. It looks like it had pretty much all dissolved even in ethanol. So I'm glad I did the extra little experiment. I had a little hunch about that because ethanol is the most common solvent that organic chemists use to dissolve organic molecules because it has that 2-carbon non-polar, or maybe 1 carbon, you might consider it non-polar area, and then the alcohol end of it's polar. And it kind of has just the right balance. It'll dissolve a lot of things, ethanol. It's the most common solvent to use to try to dissolve organics. So there we have it. The ethanol, after heating, dissolved most of it. There's still a little bit on the bottom, if it'll focus, that didn't dissolve, but most of it dissolved. And then the water, very little dissolved, and it floated to the top, so water is more dense. The methanol did not dissolve much. It dissolved a little bit though. It looks like it has a little yellow color. And the hexanes didn't seem to dissolve much, maybe a little bit.